Hello and welcome to the lecture series on principles of microeconomics. In my previous class, I have talked about the definition of marginal utility and total utility, and we have also seen the mathematical expression of marginal utility and total utility. I have also given you the schedule of marginal utility and total utility. But in today's class, we are going to talk about the relationship between marginal utility and total utility. So let's get started. First of all, total utility, as usual, the definition is it is the sum total of utility derived from the consumption of all the units of a commodity, and marginal utility refers to the additional utility on account of consumption of additional unit of a product. So these are the definitions of total utility and marginal utility. The mathematical expression for marginal utility is given by marginal utility is equal to the ratio of change in total utility to change in quantity, or it can alternatively be deduced as total utility n minus total utility n minus 1. So let us look at this schedule which talks about the quantity and total utility, and with the help of that we derive something called as the marginal utility using this formula or this formula, either ways you like. So here we have been given quantities of a good and the associated total utility with that good. So first quantity is giving me total utility of 12 units, second is giving 22, third is giving 30, fourth is giving 36, fifth unit is giving me 40, sixth unit is giving me 41, which now you can see that total utility is increasing and it reaches maximum at this point, unit 6, wherein it is reached to 41. Then at 7th unit it is becoming 39, and 8th unit it is falling to 34. So we can see that as the units of consumption are increasing, the total utility increases but up till a certain limit and then again starts to fall. So here the unit is 6th unit. So now what is the underlying change in quantity? It is changing by from 1 to 2, that means only 1 unit, 2 to 3, that means only 1 unit, 3 to 4, that means only 1 unit. So we are going to make one more column here which is going to talk about delta Q. Delta particularly means change. So here this delta is talking about the change. Here delta Q means the change in quantity. Okay, so this is talking about the change in quantity. So what is the underlying change in quantity? The quantity in first unit it is changing only 1, second is also 1 unit only from 1 to 2, 2 to 3, 3 to 4. So the underlying change in quantity is by 1 unit. So therefore this entire column is with respect to all these changes in quantity, the change in quantity is by only 1 unit. So therefore all these are written as 1. Thereafter we are also going to make a column which is going to talk about change in total utility, because these are the two important things which we require to find out the marginal utility. So total utility, how much it is changing? First is going to be the same because we don't have a preceding unit, so 12 will remain the same. Now let us see, from 12 it has increased to what? It has increased to 22, that means 22 minus 12 is giving me 10 units. Then from 22 it moved to 30, so 22 to 30, 30 minus 22 it is giving me 8 units. From 30 to 36 it is giving me 6 units. Then 36 to 40, then 40 minus 36, 4 units. Now 41 to 40, only 1 unit. Now we can see that marginal utility, it was rather total utility, or the change in total utility is 10, 12, 8, 6, 4, 1. What is the underlying change here? The change I am talking, I am not talking about total utility, the change in total utility I am talking about. The change is minus 2 because from 41 it is come to 39. So 39 minus 41 is minus 2. Then 39 to 34. So 34 minus 39 is minus 5. So this is my change in total utility with respect to change in quantity. As the quantity was changing, total utility was also changing. Okay. So now the formula for marginal utility is given by this, that is change in total utility divided by change in quantity. So here change in total utility is how much? In the first case it is 12. What is the change in quantity? 12 divided by 1, it is giving me 12. Then 10 divided by 1, it is giving me 10. 8 divided by 1, it is giving me 8. So like this we can see that the marginal utility is very high when the first unit of first unit of the commodity is consumed, but it goes on decreasing and it also becomes negative in this case wherein you can see that, so the marginal utility declines, it becomes 0 and it also changes into negative as well. Okay, so this is how we can look at the marginal utility, and this is how we can calculate marginal utility given Q and TU. Okay, given Q and TU. Now these two columns I have deduced because so as to make sure that you know how the formula is and how do you put this in the formula and then derive the marginal utility. So therefore this is the column which is talking about the marginal utility. I hope this schedule is pretty much clear because I am going to plot this schedule in the graph here. So let us look at how do we do that. So here I have just named these units. The first unit is A, B, C, D, E, F, G, H. So the first is, now here on the x-axis we are going to talk about quantity, on the y-axis we are going to talk about total utility in the first graph. Okay, first segment of the graph. Total utility here, marginal utility. So total utility is 12, 22, 30, 36, 40, 41, 49, 35. So max to max 41 we require. So 5 units I have taken. It reaches 45 here and 1 to 8 here. So at the first unit the total utility is 12. So combination or point A is looking at this combination 112. Point B is looking at 222. Point C is looking at 330. 4 is 436. So like that we see at point F, which is unit 6, total utility has reached maximum. Total utility reaches maximum at point 6, unit 6. Okay, so here total utility reaches maximum and then again it is falling down, as we can see from the schedule per se. So this is when you join all these points, I get something called as the total utility curve. Okay, just I have taken the points and I have plotted it on the graph. So this is my total utility curve. Okay, let us now move to the marginal utility curve. So here the marginal values are given it in this column. Okay, so this is column 1, column 2, column 3, 4, 5. So now we have to look at column 5 and column 1 because on the x-axis I am going to look at the quantities and on the y-axis I am going to look at the marginal utilities. So here first column and fifth column we are looking. So 1 and 12. So here 1 and 12 is denoted at this point. Okay, 1 and 12. So okay, here I will write only A, B, C, D, E, F, G and H. Okay. Similarly, point B is denoting 2 and 10, C is denoting 3 and 8. Okay, so this is how we have plotted when you plot all these points and when you join it, you get the marginal utility curve. Now we have to remember one important thing. The marginal utility curve intersects x-axis, that means the value 0 when total utility is maximum. So you can see that when you drop a parallel from the maximum point of total utility to the point, or you allow it to intersect the x-axis of the marginal utility curve, you will see that the marginal utility curve and the perpendicular which you are dropping from the maximum point are intersecting at point 0, at point O, or at the point x-axis. Okay, so this value of marginal utility at this point is 0. So let us look at now what can be the possible relations between marginal utility and total utility. The first is, as more and more units of a commodity are consumed, marginal utility falls. So we can see from here, from 1 to 2, yeah, it is going down. Third, it is going to 8. When fourth unit is consumed, it is becoming 6. When fifth is consumed, 4. Then sixth is 1, and then it becomes negative. So we can see that as more and more units of a commodity are consumed, marginal utility goes on diminishing. It becomes 0 or negative as well. So as you consume more and more units of a commodity, the marginal utility might become 0 or it might end into negative coordinate, as it has happened here. At point 7 it is becoming negative 2, at point 8 it is becoming negative 5. So this is how the first important thing about marginal utility curve is deduced out of this graph. The second is, as long as marginal utility is positive, that means from A, B, C, D, E, F, G, it is falling down, but it is at least in the positive coordinate, right? It is in the positive coordinate. So as long as the marginal utility is positive, total utility in this entire segment, if you look at it, marginal utility is becoming 0 at this point. The total utility when marginal utility is positive is increasing. So this is the second relation. Okay, so as long as marginal utility remains in the positive direction or positive coordinate, total utility is increasing. Okay, so this is the second point of relation between marginal utility and total utility. Third point is very important. As total utility becomes maximum, marginal utility becomes 0. As we have dropped a perpendicular and seen, when total utility is max, marginal utility is 0. The next and last relation is when marginal utility becomes negative. As soon as marginal utility enters into this negative coordinate, which is unit 7 and minus, this is obviously talking about marginal utility in the negative coordinate. Okay, so here as soon as it moves to 7 units, as soon as you consume one more unit and marginal utility becomes negative, you will see that the total utility curve is going on declining now. At point G, the total utility is fall. You can see a fall from 41, it has gone down to 39 at the 7th unit, this total utility. As you further increase your consumption from 7 to 8, 34, so you can see that as marginal utility comes into the negative coordinate, total utility starts to decline. So this is how you can look at the relationship between total utility and marginal utility. The relation is, as long as marginal utility is positive, total utility increases. When total utility is maximum, marginal utility is 0. When marginal utility comes in the negative coordinate, total utility starts to decline. You have seen how do you calculate marginal utility mathematically and with the help of this schedule as well. So I hope you understood the concept of both total utility and marginal utility. Also, how do you formulate it, or how do you look at it from the mathematical perspective, and how do you deduce that with the help of a schedule per se of quantity and total utility, and then plot this schedule to derive the curves of both marginal utility as well as total utility. Here it is total utility curve, here it is marginal utility curve, and the relationship between both total utility and marginal utility. So I hope the idea is pretty much clear. Please stay tuned for more. Thank you.